Christmas tree. Isn't it nice? Yeah, a box full of parts for another small project. uh, as you know, I'm rebuilding a vintage power supply card link, and well, I need electronic load to test the whole thing and to play around with it a bit. And at the same time, I need AC load because I want to characterize the transformer in that old supply a little bit more, how it yeah, behaves under load. And while DC constant current electronic load is quite simple to build. There are a lot of things out there on YouTube how to do that. A DC load, especially a DC constant resistant load, it's quite complicated. So, and yeah, I collected a few parts here in that box that we will need for AC, DC, constant resistance. Constant resistance, yeah, the holy grail. AC, holy grail, DC load. So we have here a length of aluminium flat bar. Yeah, put that somewhere. I have some sheets of clear, that's in German, but that's basically clear self-adhesive laser printer film. And yeah, that will be a surprise. I hopefully need only one sheet for of that, or two sheets, we'll see. Yeah, of course I have a plan of how the whole thing should look like. We have a detailed look on that in a moment. Yeah, copy of the same plan, don't know why. We have a small aluminium case. We have switches, and these are double throw on, off, on switches. Okay. What else is in the box? Yeah, some old metal mesh. An empty bag. That's not good. Oh yeah, a big switch. I mean, you can probably guess what that is for. That's the main on-off switch, and it's really only an on-off switch. Okay. Oh, okay, that should be a surprise. A whole lot of halogen. There are more in there. Halogen light bulbs, 10 watts each. And yeah, okay, these will be our resistive elements. And yeah, why halogen light bulbs. I mean, you can use, for example, 10-watt resistors, but put that aside and yeah, some, how do you call it, soldering something, data, yeah, for the internal wiring. Let's see what else. Of course, 2 binding posts, black. Yeah, black and black because I mean it's AC capable, so yeah, it doesn't have a polarity, the whole thing. Then it gets easier. Whole lot of screws, M2 and M3. They are actually bolts, as I learned, because the way the way I'm using them, they are bolts because I have, oh, these are M2 washers, by the way, because I have nuts. And if a screw goes into a nut, it's, in English, it's obviously a bolt. If a screw goes directly into the material, it's a screw. Screw you, English people. We don't have that distinction in the German language, but okay, bolt and screw. Okay, I will use the screws as bolts. All right, and yeah. Oh, this actually belongs, and these are screws. They belong to the case. Something else. Yeah, another of that soldering posts. Yeah, soldering posts, I guess. I won't need both, I guess. Yeah. A whole lot of sockets for the halogen light bulbs. More bolts. Yeah. Some of these nice special thumb nuts. Yeah. And 3. All metric, of course. More nuts. And yeah, that's it. So the plan here is from electrical side to use all these light bulbs. I just put that out of the way. To use all these light bulbs as load. And we use all the switches to switch the load. Give me a sec to get that out of the way. And then we have a look at what I thought could be the circuit diagram for the whole thing. So, and this would be the circuit diagram, and it's actually quite simple. So we have the 2 binding posts, one of them going through the big switch, and then we have basically 2 AC/DC buses, one here at the top and one below here. And the light bulbs, and I've drawn only two are directly connected, one to the, let's call it phase when we're talking about AC, and the other is connected to neutral. And then the whole thing goes to the middle contacts of one of these switches. So and ignore these remarks here, that's only for me, for orientation. And if the switch, seen from the side, yeah, like that, is in the middle position, obviously both light bulbs are off. No problem. If you put the switch in the upwards position, and you have to be careful that this little symbol here, what's up and down of the switch, you see there's a little index groove here on the switch. So I defined that as up when it goes into the case. If you, let's put the meter into view 2. If you put it into the upwards position, nothing happens. I'm measuring between the middle contact and the upper contact. If you put it into the downward position, obviously the upper contacts are connected to the middle contact. So we are down, and our switch connects the upper contacts, these ones. And that basically means the current now flows from our phase through that little, yeah, it's basically only a short bridge at the back of the contact, back through the other bulb to neutral. And that means we have the two light bulbs in parallel, and so we get 10 watts at 24 volts, because that's the first mistake, sorry. This is obviously 20 watts each, sorry. 20 watts at 24 volts, because we put them in parallel. If we throw the switch into the other position, our throwers will be connected to the lower contacts, and what now is happening is one light bulb is going from phase through neutral, and the other light bulb is going from neutral to phase. And we have both light bulbs in parallel, which gives us 20 watts at 12 volts. So we can, yeah, the switch is always switching on a load for 20 watts, but one time for 12 volts and one time for 24 volts. And the reason I've positioned or designed it, sorry for the beep, just getting the switch, designed it this way that you have to throw the switch upwards for 12 volts is simply yeah, to avoid destruction of anything, either the light bulbs or your source you're testing. Yeah, it's highly unlikely that you put a switch accidentally into upwards position when it's in the front plate, but you might, you know, just something might fall on it, or And if that happens, it switches to the position where it can take 24 volts, and obviously it also has the higher resistance to your, presents the higher resistance to the load you connect. Oh, the source, not load, sorry, the source to connect. So yeah, that's safe. And if you want to go to the 12 volts, 20 watts, which presents, of course, a lower resistance to your source, you have to make an effort to switch, to throw the switch upwards. So yeah, that's at least the idea I had to make it a little bit more safer. Yeah, of course the on-off switch will be positioned in exactly the same way, so so on will be in the upwards position, just to be safe. So off is simply throw it down. And of course, yeah, being that very old style design for a load, I use throw switches. Yeah, they're nice. I like them. So on the top of the case, all the light bulbs go, and therefore we have to mount the sockets here, which are a whole lot of holes to to drill in. And yeah, also the aluminium flat bar will go on top. And the idea here is, just doodle this out, lost doodle. If you look at it from the side, we have our sockets with our halogen light bulbs, which are getting quite hot, of course. And then we take, just as a measurement, security measurement, so I don't burn myself, that metal mesh, and bend it around like that. So you don't accidentally touch the whole stuff, okay? And yeah, to fixate that metal mesh, the aluminium flat bar will be put in parallel here and here, with, of course, some nuts and bolts going through it. Yeah, not exactly good mechanical engineering, huh? And two of these bolts will, or yeah, two on each side, will actually go the whole way through into the case, and will be secured with a thumb screw. So you can go in and open it up and lift the whole thing up to change light bulbs, because the light bulbs will eventually fail. Yeah, that's the nature of things. Or maybe your source is putting out a whole lot more than you know, the 24 volts this thing is designed for, or yeah, you do accidentally switch it on a 24 volt source to, you know, 12 volts. Two more bolts on each side will only go, and yeah, through the two pieces of flat bar and the metal mesh, keeping the flat bars and the metal mesh together. So this is really, will be, if it all works out, really a unit you can unscrew and lift off, and then you have access to the light bulbs to change them. Yeah, that brings me to another question. Or a design decision. Why use light bulbs? I mean, first of all, light bulbs get very hot. That's a disadvantage and an advantage, because my 10 watts of heat I'm generating in each light bulb basically can dissipate very easily, because the temperature differential between the light bulbs and the surroundings is very high. You don't need a heat sink. Yeah. I thought about, you know, using big 10 watt resistors, but these big 10 watt resistors in an aluminum case, you need to attach them to, just right, some kind of heat sink to dissipate the 10 watts. There are only a few on the market that you can run 10 watts through without a heat sink. And yeah, that would have made the whole thing bigger, of course. You couldn't fit it in such a small case. So you can, if you don't use it anymore, throw it away into some box, and it won't take up much space. And the second thing is, these resistors are, of course, more expensive than some Chinese halogen light bulbs and sockets for them. Yeah, that was the main design decision. Besides, no, that was not the main design decision. The main design decision was, it's cool when they radiate light. Yeah, if you turn up your source, your linear regulator, your lab power supply, whatever you're testing, and things light up. It's cool, isn't it? Yeah, let's talk a little bit about the front plate. Nothing much to see here. So this will be, yeah, the front with the two binding posts, 5 of the smaller switches, and the big switch. And now it's time to get to work. Now, marking all these holes on the case using a caliper or something else is quite yeah, a feat. Yeah, it's too much work. And if you are not concerned about yeah, being off, let's say, 1/10 of a millimeter, I use another method. We have here a nice drawing, and we have our case, and this should match really 1-to-1. Yeah, just, oh, wrong part of the case. That should really match 1-to-1. So what we can do is simply cut out the drawing and tape it to the case, and then we can center punch all the holes we need. So cutting out that stuff needs some precision. Okay. Yeah, we have to remove the protective plastic film, which should hopefully be easy. Okay, now we simply tape this to the top. Yeah, that's better. Okay, and now for the front plate. So, front plate, almost finished. Okay, now to the center punching. This might be easy. This not so much. I have to think about how to support that one. Okay, yeah, the edge, as I said, it's supporting this is not so easy, but the edge of the desk and a little bit of wood, and it's fine. Yeah, let's get to it. Looks reasonable. Ready to be pre-drilled. Now we have that one, which is also a bit complicated. Lot of holes. And by the way, I won't center punch these holes here where the flat bar goes. That stuff, because I will first cut the 4 pieces of flat bar we need here and then clamp it together, then center punch the flat bars and then drill all 3 pieces in one go, so I can be sure that all the holes really line up. Ooh, these are a whole lot of holes. And that's it. Everything center punched. And yeah, of course, an effect of the center punching is that the case bent, but we can bend this back. And yeah, now pre-drilling the holes. Yeah, I know I said you have always to secure your workpiece, but there's really no way how to secure that thing. At least I haven't found one. So yeah, let's pre-drill with carefully with 2 millimeters. Okay, next size is 6 millimeters. And I think I'll do the last two holes, which should be 7 millimeters in one go. That was also not too bad. Go here to 7 millimeters too. And finally 12 millimeters for the big switch. No. I do 10 millimeters first because that's a little bit too hot for me, that hole. And now we can go to 12 millimeters. Okay, wonderful. Let's try out if everything is fitting. Yeah, yeah. Something is amiss here. No, it isn't. Fits. 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 Wonderful. My nice big switch. Yeah, fits too. And oh, what am I missing? Sorry, searching for the binding posts. They should be here in the box somewhere. I'm sure they were in the box. Ah, here they are. Had to fit in here. Oh, there's a little index. Can you see it? Yeah. So we might need to apply the file, but I will do that in a second after I cleaned up that piece. Yeah, let's deburr that stuff. The backside is really bad. It's really just the smallest of black on black. Smallest of indents. Yeah, here you see it. What we need. So let's do this. So everything fits. Front plate is ready. I will clean up and then we go for the top. Yeah, securing that piece of the case is a little bit easier, so drilling will hopefully be a bit easier. Now, these are obviously for the socket, for the halogen lamps. And yeah, I'm not sure what I thought about the diameter of these holes. They are for the cables. I initially said 2.2 millimeters. Yeah, but it's not really critical. I think I go for 3 millimeters just to give it a little bit of wiggle room. Got to get the right drill for that. Yeah, after considering real life, I mean, this is a 3 millimeter drill bit. This is 4 millimeters, so yeah. I guess I go for 4 millimeters for the cables to get them through the case. That will give me enough tolerance, and though they won't scratch on the aluminium with the isolation. So, yeah, it looks ugly from the backside. I have to clean that up. But yeah, I think we are ready to test fit the lamp sockets, which will be held down by 2 and 3 screws. And we could first test fit just the lines, the cables. Yeah, that's a nice loose fit. And yeah, let me get some of the M2 screws and we see if the 2 millimeters are enough. So yeah, the screws have actually some wiggle room inside socket, so yeah, maybe I get lucky. We'll see. Let's try that. Yeah, fits. Yeah, looks good. Now I just have to clean up these holes and yeah, then we are on to the bars. Yeah, nothing to it, just, you know, a lot of manual labor. And I'm asking myself, why do I do this manually? That's it, and after the holes are cleaned up, it's also quite easy now, again, to bend it back into shape. That was just because the stress of the material of center punching all these holes, it bended it. But now that the holes are drilled, it's, yeah, the stress is gone from the material and everything's fine again. Do I see some dirt here? No, that's paper. Yeah, next up is doing the bars to hold the mesh over the light bulbs. Yep, I got the big guns out. We need 4 pieces of that aluminium flat bar of 140 millimeters. And yeah, let's see what we can do. Let's see if I was right. Maybe a bit too much, but if I file off the saw edges, it will be just fine. I hope. Okay, 3 more. 4 pieces of flat bar with yeah, good enough. Yeah, some filing. A few points about yeah, this kind of saw. I mean, you can buy them for I don't know, 20 bucks, 30 bucks, 40 bucks in your home improvement store. Here in Germany we have OB, Bauhaus and the likes. And these cheap, in German, Gärungssäge, I looked the English word up, they're just shit. They're shit. I mean, often in the exit area of the home improvement market, they have some of their cheap models installed on desks, so you can, yeah, cut your wood you bought or whatever to a reasonable size to, you know, put it into your car or whatever, and just have a look at these things after some hard use, yeah, by customers, about the tolerances. And you can spot them because, you know, the guides and the cheap ones are plastic. They're plastic. That's simply bullshit, yeah. And if you want a good one, you will have to invest 100 bucks or so. And this is a Cooper model. These are not perfect. There are better ones out there, but at, I don't know, about 100 bucks. It's reasonable. It's reasonable. You have to do some work on it to get it really fine-tuned, but it's reasonable. And yeah, second tip, if you buy the original Cooper metal blades, there's so much protective paint on it that they won't fit through the guide slots. Yeah, that's a fact. I bought that original Cooper metal blade, wouldn't fit through the guide slots. So you first have to, yeah, grind down the protective paint on it to get it fitting. But okay, back to filing again. Four pieces of flat bar. Now that the edges are nice and cleaned off. Yeah. Good enough. I plus minus a tenth or 2 millimeters, that is. Yeah, it's okay. Now that I have my flat bars, it's the same routine again, really. Well, cutting out and attaching it to 2 flat bars at the same time. And so we have a real nice sandwich, which, yeah, cannot shift. That's good. And we do the same thing with the other pair of flat bars. Okay, that's it. Some center punching is due now. Now we center punched the stuff, and now we have to fix it to the case. And then we drill it. Yeah, the idea is to drill all 4 holes in one go through all 3 layers of aluminium. And yeah, don't loosen the clamp in between. Let's see how that works out. And yeah, I'm drilling with 3 millimeters, not pre-drilling with 2 millimeters. That, yeah, I feel lucky. And it's for M3 screws, so 3 millimeter screws. And now the same thing for the other side. Second bar. And yeah, in between I I marked the bars because yeah, the placement of the holes is not that exact. So, but each bar will fit perfectly on its side in the right orientation. So, yeah. Yeah, let's clean up a little bit, and then we come to this part. Yeah, some protective cover over the light bulbs, so I won't burn myself. But before that, I clean up the holes a little bit. Okay, that's it. Now we can go to the metal mesh. So the idea is here to bend the metal mesh to some form like that to go on top of the case. Yeah, connected removably with the metal flat bars. Yeah. Bending metal is not my forte, and it's an art. It's an art because when calculating the length, the initial length, you have to cut out, you have to yeah, take into account the thickness of the stuff, yeah, the radius of each band, and yeah, I just wing it. So first we have to cut the whole thing to the width of my flat bar. First thing I want to do is put some holes through the mesh using my bar as a template. Yeah, and I was careful to have the orientation of the bar right. Yeah, that's my top bar, number one. It goes, yeah, my index is to this side, so this will be affixed that way. And now I just screw the bars on temporarily to the mesh and bend it, hopefully. Yeah, nice bend. So, yeah, according to plan, yeah, we've made that bend now, and now we have to bend over this side, and for that operation I have to remove the bar again. And we take a piece of that wood, yeah, align it and bend the other side. And just if you're wondering where the 43 millimeters come from, that's the width of the wood, and it should be, just a second, yeah, it's enough room for the light bulbs and the sockets. Yeah, I just have that wood, so I'm using it. Second bend in. It's be a little bit softer, rounder, but that's okay. Now we have to go the roughly 72 millimeters over. That's the width of the whole contraption. And bend down again. And yeah, I do this. How do I do this? Yeah, it's clear I have to clamp it down again. Could actually work. Okay, next bend would be back around. Yeah, looks not that bad. And now I have this was the one which I already did. Put them to the side, and now comes number 2. Okay. Careful. This was number 1 in this direction, so this is number 2. This is the top piece which would go in there. And now I have a wee bit of a problem, as you can see. Yeah. Number 1, that direction. Number 2, this direction. I have to open the bend again, I guess. Or take the second piece and drill from here. Nah. Yeah, seems like I maneuvered myself here in a little bit of mess. Yeah, let's open that bend again. And cut here. Okay, I'll try my best. Uh-oh. Yeah. I might have cut that a wee bit off. Yeah, nobody will see afterwards. Well, it's not as catastrophic as I thought it might be. Well, it's kind of a tight fit, but that's not too bad because, as you remember, the middle two screws won't actually go through the holes. I will take shorter screws here, and yeah, let's put that together on the other side. Success at last. So I ended up filing slots. So for the nuts, for because I bought screws that were too short. Yeah, well, I will do that for the other side too, and yeah, you don't need to see that in time lapse. It's a mess, but anyway, filing slots. Yeah. So after a lot of filing, it finally fits together. It's time to, yeah, clean up what's ever left here of the adhesive, of the tape I used, and put it all together.